Good morning to all. In the last class I taught you about one of the most important problem in the balancing of rotating mass, right? In this class I am going to teach you about another one most important balancing of rotating mass problem, right? Read the problem. Four masses A, B, C and D as shown below are to be completely balanced. Completely balanced. The value will be the plane A, B, C, D, the mass and radius. The mass A they didn't given. The mass at B 30 kg, C 50 kg, D 40 kg. The radius at A 180 mm, B 240 mm, C 120 mm, D 150 mm. The planes containing masses B and C are 300 mm apart. The angle between planes containing B and C is 90 degree and B and C make angles of 210 degree and 120 degree respectively with D. In the same sense, find the magnitude and angular positions of mass A and the position of planes A and D. Position of planes A and D. In the previous problem, they given 4 masses and they didn't mention the angular positions, right? But in this problem, they given the planes 4, but they given the mass 3, and also they given the radius 4, and 2 angles, 2 angular positions, but they didn't mention the position of planes, two position of planes, right? So we need to find that mass and also that angular positions, and the space between the planes, right? For that I am going to draw a space diagram, position of plane diagram. They given the 4 masses, right? A, B, C and D, and here they mentioned the planes containing masses B and C are 300 mm apart. So I am going to draw a B and C first, 300 mm apart. It is spaced between 300 mm, right? Then I am going to consider reference plane B or C. Then only we can able to identify the distance of A and D, right? Because I am going to consider a reference plane as B, means this B to A, what's the distance? Otherwise B to D, what's the distance? Otherwise we can take the reference plane as C also. Suppose I am going to you are going to take the reference plane as C, means C to A you have to mention a letter I as distance and C to D as some distance, right? Here I am going to take the reference plane as B. The distance is I am going to consider as Y, and B to D distance as considered as X. Okay, this is the main thing. Then they mention the angle between the plane containing B and C. So B to C angle is given. So I am going to mark the origin and draw a horizontal line for B. And B to C angle will be 90 degree, right? B to C angle will be 90 degree. So I am going to draw a perpendicular line to the B and mark it as the C, that is 90 degree. Then B and C makes angle of 210 degree. And 120 degree, right? B makes 210 degree. B to D 120 degree, 210 degree, and C to D 120 degree, right? They mention B to C, B to D 210 degree, and also they mention C to D angle 120 degree, right? For the same only, for the single plane D plane only they mention the angles, the exact angles, right? The value will be 210 degree from the B plane, right? These are the data they given. Then what we need to find? the magnitude and angular position of mass A. Mass of A and angular position theta A we need to find. Then the position of planes A and D. Position of planes A and D. The distance from the reference plane X and Y, that we need to find. Right? These are the things only we need to find. For that, I am going to draw a tabular column. Right? Tabular column. Plane, mass, radius, centrifugal force per omega square, distance from reference plane, coupled per omega square. Right? Here we know the planes A, B, C, D. So directly we can write the masses. Mass A we don't know, so MA. Mass B 30, C 50, D 40. First radius A plane 0.18 meter, B 0.24 meter, C 0.12 meter, D 0.15 meter. Right? For centrifugal force per omega square, for finding the centrifugal force per omega square, we need to multiply the mass and radius, right? Directly multiply that 0.18 MA, 7.2, 6 and 6, right? After finding the centrifugal force per omega square, we need to check the distance from reference plane. Distance from reference plane, right? Distance from reference plane, this is a reference plane, right? Reference plane to A. This is in the which direction? Left side direction, right? Left side direction negative, right side direction positive. Anyway, you have to take referring the graph. Referring a graph, vertical to y direction, y axis to leftwards means negative, right? Rightwards means positive. That's a basic concept. That basic concept only we are following here. So from the reference plane to A plane is a left direction. So this is a negative. The distance is y, minus y. Okay. Then distance from reference plane B to B 0. Then B to C 300 mm, so divided by 1000, 0.3 meter. And B to D, that is X, positive. Right side direction, so positive X. Then how we can find the value of coupled per omega square? We need to multiply the M R into L. Already we multiplied the M into R value for centrifugal force per omega square. So we can multiply these two things, centrifugal force per omega square value and distance from reference plane value. Finally we got the coupled per omega square. The value will be minus 0.18 MAY. For plane B 0, for plane C 1.8, for plane D 6x. Okay, right? After finding this value, after completing this tabular column, we need to check the possibility of drawing diagram. Which one have minimum unknown values. Here we have plane A and plane D have unknown values. Here we have only one unknown value in the plane A. So I am going to draw a force polygon first. Because of minimum unknown value. Right? This is a basic reference, right? So I am going to draw a horizontal line for this value. Can you draw this 7.2, 6 and 6 in a single sheet? No, it's not possible, right? Your notebook, it's not possible to draw exactly. So I am going to take the scale ratio. That is 0.5 kilogram meter equal to 1 centimeter. 0.5 kilogram meter equal to 1 centimeter. Sorry. 2 kilogram meter equal to 1 centimeter. 2 kilogram meter equal to 1 centimeter. 2 kilogram meter means divided by 2. 7.2 divided by 2, 3.6. So we can able to draw the diagram, right? I am going to draw a horizontal line. horizontal line, otherwise parallel to B plane. Parallel to B plane. Mark the origin and parallel. Draw a parallel line to the B plane in the angular position diagram. Right? Parallel to the B plane, and the value will be, the length value will be 7.2 divided by 2. That is 3.6. Right? Mark that. And for the C plane, 6 divided by 2, 3. Right? Draw a parallel line. Draw a parallel line to the C plane from the B point. From the B point, and mark the value. That is plane C. And for D plane, the value also 6. So 6 divided by 2, 3. Draw a parallel line to the C plane, D plane. Draw a parallel line to the D plane from the C point. C point, mark the value. Right? Finally, the diagram is incompletely available. So we need to connect with the dotted line. Connect with the origin. D to O. We need to connect with the origin with dotted line and measure that value. The value will be multiplied with the scale ratio. Finally, we got the value 3.6 kilogram meter. That is, we need to equate it to 0.18 MA. That is the unknown value, right? Finally, we got the mass of A value here. From here, right? After that, we need to multiply that value. That's all. Okay. After that, we need to find these values, x and y value. How you can find? We need to draw this coupled polygon diagram. How you can draw? Here we have only one value, 1.8 meter, 1.8 kilogram meter square, right? Then how you can draw? I am going to mark the origin. And this is a plane C, right? Plane C. What's the value? 1.8 kilogram meter square. Directly it's possible to draw, right? I am to take the parallel to the C plane. Draw a parallel line to the C plane from the origin. The value 1.8 centimeter. Here I have taken the scale ratio 1 kilogram meter square equal to 1 centimeter, right? Parallel to the C plane and mark the value. And here we need to draw a projection line. From where? We need to draw a line C to D, 6x, C to D. Already we know the angular position value, right? That is angle value. So we can draw a parallel dotted line to the D plane. Parallel dotted line to the D plane from the C point. With the parallel dotted line to the C plane, D plane. Okay, right? After that, we need to draw a parallel dotted line to the A plane. Parallel dotted line to the A plane from the origin. It will be intersect at one point. That is point D. And measure that values C to D value and equate to 6x. C to D value and equate to 6x. We get the x value. From that we get the x value. The value will be 0.383 meter. Right? After that, we need to measure the O to D value and equate to minus 0.18 MAY equation and find the value of y. Here we can substitute the value of MA. Already we found and find the value of y. The value will be minus 1 meter. The value will be minus 1 meter. After that, we need to draw a position of plane diagram again. Position of plane diagram again. Y means the values based on the value, the space diagram, space value. We need to draw a diagram. Here we mentioned y, B2A is a y and B2D is a x, right? X value is the 300 mm. Here we got the 383 mm, that is 0.383 meter, right? Same concept only we got. Here we got the minus 1 meter. This is a minus 1 meter, right? This is a 0.3 meter. This is a x is the 0.383 meter. Okay, right? These are the conditions. In the next class, I will teach you about the another one most important problem. Thank you.